All right, picture this. You're standing outside a dimly lit motel right on the edge of town. The windows are totally shattered, the door is busted in, and inside, well, it's an absolute mess hidden in the shadows. Welcome to The Explainer, folks. Today, we're diving into the gritty true story of a wrecked motel room and the literally glowing chemistry that investigators use to decode invisible evidence. We're talking about dark secrets that perpetrators thought were washed away forever, suddenly brought back to light by pure science. Let's get into it. So our story really kicks off with Officer Stone pulling up to this gritty scene. The motel manager is totally spooked, telling him the room was rented to a guy named Frank Carter. Now the thing is, Carter hasn't been seen in 3 days, not since he originally checked in. And while Carter's record isn't exactly spotless, the guy has absolutely no history of violent crime. But the second Stone steps into that chaotic room, the tension just spikes. Right there on the floor, there's some really suspicious red-brown stains and a partial shoe track. It's exactly what the initial dispatch report suggested. All these little details are heavily hinting at a really brutal, bloody struggle. Which, of course, leaves us with one massive, glaring question. What on earth happened to Frank Carter? I mean, the visible evidence is super alarming, but honestly, it's just a tiny fragment of the whole story. There just aren't enough obvious naked-eye clues for Officer Stone to piece together the exact narrative of what went down in that room. So he makes the call, he brings in a detective and a full crime scene investigation team. And they do the usual, right? They inspect, they photograph, they sketch and measure everything they can see. But to actually find Frank Carter, they need to figure out a way to see what they literally can't see. They need some serious scientific intervention.
Enter the star of our show. To reveal the hidden truth of this motel room, the CSI team breaks out a very specific, almost magical chemical tool, Luminol. Now, if you want to get technical, it's known as 3-aminophthal hydrazidide. But basically, luminol is a chemical solution used by investigators for one very specific job, to illuminate faint or even completely invisible traces of blood at a crime scene. It's kind of ironic when you think about it. It's the ultimate tool where you actually have to turn the lights off just to see things more clearly.
Now this isn't exactly a brand new trick. Way back in the 1920s, researchers figured out that luminol molecules would actually glow if you mix them with an oxidizing agent and expose them to certain chemical compounds. But the real game changer? That didn't happen until 1937. That's when a brilliant German forensic scientist named Dr. Walter Specht realized, wait a minute, one of the compounds that triggers this glowing reaction is actually blood. He introduced it to the forensic world, and the idea spread like wildfire. Fast forward to the present day, and that exact same science is exactly what Officer Stone is relying on to track the unseen trail in Frank Carter's room. So how does this actually work in practice? Well, it's like a tiny chemical explosion. First, investigators mix the luminol with an oxidizing agent just to prep the solution. Then, they pitch black the crime scene and start spraying. The magic happens when that fine mist hits hemoglobin. You know, that's the protein packed inside our red blood cells. The luminol molecules rapidly oxidize, they get highly excited, and then, as those molecules inevitably settle back down to their normal, relaxed state, they release energy. And that energy, it takes the form of this eerie, faint blue-white glow. What you're seeing here is a textbook, yet totally amazing example of chemiluminescence. Now, chemiluminescence is basically just the scientific term for the process where a chemical reaction emits light. It's actually the exact same principle that makes a firefly glow on a summer night, except here it's being used to catch criminals. Just put yourself in Officer Stone's shoes for a second. You're standing in that pitch-dark motel room, the lights are switched off, the forensic team begins to spray, and suddenly, these glowing blue-white trails just start emerging right out of the darkness. It's completely surreal. But hold on, because there is a huge catch, and it makes things incredibly stressful for the investigators. 30. That is the number of seconds this incredible chemoluminescent glow actually lasts. 30 seconds! The light fades incredibly fast. Because of this super short window, our CSI team can't just spray the room once, stand back, and take a leisurely look around. No way. They have to continuously, relentlessly, keep spraying the solution in the dark, tracking that fleeting blue light step by step to follow the blood trail. It adds this massive, intense, ticking clock to the whole investigation. And what's truly fascinating is that this glow doesn't just act like a neon sign pointing out blood, it actually tells a detailed story. It's all about reading the patterns. For example, if the luminol reveals large, round drips, investigators know they're probably looking at a slowly bleeding wound. But if they see a fine, mist-like spatter, well, that strongly suggests a high-impact wound, maybe from a firearm or some kind of motorized tool. And then there are voids. This is when they find a completely blank, dark space right in the middle of a glowing spatter. That absence of a glow is a huge clue. It means an object or maybe even a person was standing right exactly there, blocking the blood from hitting the wall. Oh, and of course, glowing footprints and drag marks, those map out the exact physical movements of a body being moved through the scene. Now, you might be wondering, hey, if I was a criminal, couldn't I just grab some bleach and furiously scrub the floors? Good luck with that. Luminol is extraordinarily sensitive. We're talking reacting to highly diluted blood kind of sensitive. This makes it almost physically impossible for a perpetrator to clean a crime scene well enough to actually hide the evidence from chemiluminescence. A criminal might scrub and bleach the floor until it looks completely spotless to the naked eye, but when a skilled investigator comes in and sprays luminol, the room lights up, and they can literally see the lingering swipe marks from the mop and sponge. The chemical reaction basically highlights their exact, desperate attempts to clean up.
So, back to our motel. As the team sprays down the dark room, a really grim narrative starts to light up across the surfaces. Right there on the kitchen countertop, the luminol reveals a glowing handprint. Down on the floor, they find spattered spots, clearly pointing to an initial impact and a serious struggle, which then bleed directly into a thick, glowing drag mark. And when they carefully follow that blue trail from the foot of the bed, out the door, the destination is absolutely chilling. It leads straight into the parking lot. This completely reconstructed trail strongly suggests that the bleeding victim was dragged outside and loaded into a vehicle.
But before Officer Stone can just slap cuffs on someone and close the book on this case, we gotta talk about the limitations of science. Remember that extreme sensitivity of luminol we were just raving about? Yeah, it's a bit of a double-edged sword. Sure, it finds hidden blood, but it's so incredibly sensitive that it's been known to react to bloodstains on objects that are literally thousands of years old. On top of that, it can give you false positives. It'll glow brightly if it hits everyday cleaning agents like bleach, or even certain materials that contain copper. It can definitely play tricks on you. Because of those pesky false positives, forensic scientists classify luminol as just a presumptive blood test. Basically, it gives you an amazing hint. It screams, hey, there's the possible presence of blood right here. But it is not definitive proof. It's not going to hold up on its own in a court of law. To get that rock-solid proof, investigators have to follow up with a confirmatory test. This uses different chemicals that react only and strictly only to hemoglobin. Once they confirm it is absolutely 100% blood, then they can run the DNA test to figure out exactly whose blood was dragged across that motel room floor.
And that's exactly what Officer Stone does. He submits a swab from that glowing trail, and the lab results deliver a massive, totally unexpected twist. The blood? It belongs to Frank Carter, the guy who rented the room, the guy with a spotty record, who the cops thought might have been running some sort of illicit deal. He isn't the culprit at all. He is the victim. He was the one attacked, dragged out of his own motel room, and thrown into the back of a car.
Just as Stone is trying to wrap his head around this terrifying new reality, the final pieces of the puzzle just slam into place in rapid succession. Miles away from the motel, a local state trooper pulls over an erratic driver. As he walks up, he spots something faint, little bloodstains right there on the rear bumper of the vehicle. They bring the car in, kill the lights, and break out the luminol. The second the spray hits the empty trunk, it instantly glows this brilliant, horrifying blue-white. There are traces of blood everywhere. They fast-track a DNA test, and it's a perfect match. The blood in the trunk is Frank Carter's. Faced with this undeniable, glowing proof from the chemiluminescence, plus the rock-solid DNA match, the driver of the car completely folds and confesses to the crime.
It's wild, right? From a shattered motel room to a dark parking lot, all the way to the trunk of a speeding car. A gruesome trail that the killer was absolutely convinced they had completely erased, brought right back to life by 3-aminophenyl hydrazide. It just goes to show how incredibly advanced and almost inescapable modern forensics has become. And honestly, it leaves us with this fascinating, kind of haunting final thought to ponder. You can scrub the scene, you can bleach the floors, but can you ever truly wash away the glow?